So when we have a controller that's returning data from a back end, naturally the topic comes up, how do we filter this data so that we aren't getting everything back all at once? You know, it's fine when we have, say, 3 books in the database, but when we have 3,000 or 30,000, you know, you don't necessarily want to run your books get method and have 30,000 records of data come back and be sent to the client. Even in JSON, that's a lot of data. So what the Web API has offered us is a way that we can, through the URL, filter the requests so that we only get the data back that we want. Now, before we launch into this discussion, I want to make a point here that a lot of times when we filter data, a lot of times that's a business requirement. We have an actual piece of business logic that requires that data to be filtered a certain way. And if that's the case, then that's something that is better suited in your application code. So you actually might want your service methods to handle that querying logic. But if it's just a matter of how much data is going to be shown on the screen at a time or what particular piece of data we happen to be looking at a time, it's mostly client-side considerations, then filtering data in this way is a really great option and keeps us from having to take our client-side code and push it all the way down to our repository or services layer. We can keep all that in the client. So one of the ways we filter data is to use the OData protocol. This is an open protocol that right now is not in huge widespread use, but it is used by a lot more than the Web API. It's something that's kind of catching on, especially if people are involved in the Microsoft stack. You're using Entity Framework or Dynamic Data or something like that, then you may have used the OData protocol before. And all OData is it's trying to create a standardized protocol for exposing data publicly and remotely, so particularly for applications like this. What happens is you use a special query string in your URL, and OData provides lots of options for us. You can use it to filter the data by particular criteria. You can use it to page your data. This is something that I like because paging usually is a purely client-side consideration, and I hate pushing this code all the way down into my service layer or my backend. You can use it to sort. Very handy for, you know, you've got a list of customer data and you want to sort by last name or something. It's not really a business logic consideration. It's just the way you want to be viewing that data in the client. And there's tons more that you can do with OData. There's a whole lot that's defined in the specification. I highly recommend, if you're interested, going out to odata.org to take a look at what you can do. Well, the first parameter I want to look at is filtering. Filtering you might think of like a where clause in SQL. It's some condition that's going to evaluate to true or false. The only downside of the filter is that it does use specific keywords that are specific to OData. So just because you know SQL doesn't necessarily mean you're going to be able to use OData correctly. It has its own standard. Sometimes it overlaps with SQL, sometimes it does not. So it does use specific keywords for that. Your filter also has to be sendable in a URL. So you can't have a filter that's, you know, thousands and thousands of characters long with all this dynamically chained criteria. Then we come to order by. This is one of those direct overlaps with SQL. Order by means exactly what it sounds like. It's a sort, basically. And your order by allows you to specify what property or properties you want to sort by, and it also allows you to specify ascending or descending. Ascending is the default, but if you want to order by descending, you can specify that. One of the things I do want to point out is that you can sort by multiple properties. So if you've ever used an Excel spreadsheet or any kind of spreadsheet, really, you know how this works. So you can sort by last name as the primary sort, and then sort by order total as a secondary sort. Order by allows you to do that. You can specify ascending and descending. And then we get into paging. This is my favorite use of the OData filters, because if you've ever had to code paging logic as part of your repository or as part of your query objects, this is just a pain. There's no really great way to take what is basically a client-side concern and push it all the way down to your business logic. So paging is kind of nice. The downside is you have to know math. And so depending on how big an obstacle math is for you, this may not be your ideal option, but It's a very simple thing to incorporate into your URLs, and I've really appreciated this feature in my own development. Paging is done by using skip and top in your query string. These things will both go into your query string. Skip will pass over a certain number of records, and so you should set skip to whatever page number you're on times however many records you want on your page. So for example, if I'm on page 3, then I want to skip 20, right? I want to pass through the first 20 records and start with record number 21. Top selects a certain number to return. So top should be set to my page size. Okay, so for example, for the first page of data, I don't want to skip anything, so skip would be 0, and top would be however many records I wanted to show per page. So let's say that's 10. So I would have skip equals 0, top equals 10. When I go to the next page, then I want skip to equal 10 because I want to bypass those first 10 records and then take the next top 10. So skip equals 10, top equals 10. Top is always going to equal 10 because that's the page size, but the skip value is going to change. It's always going to be that page size times whatever page of data I want to be looking at. So it's going to go 10, 20, 30. And then, probably you're generating these URLs as JavaScript or in hard links. So you just got to do a little bit of simple math to make sure that you're returning the data that you want. There is more that you can do with OData besides just the things that I've shown you. These are just the most common things and the ones that lend themselves best to client-side filtering. There are, for example, other OData query strings. We covered a few keywords, but if you go to the OData website, you'll see there's many more query strings that you can use to do different things with your data. There are other query keywords for filter. Okay, so when you're looking at filtering, there are several options you can use for filtering criteria. So you can get all the orders that are less than a certain total, or all the customer names that start with L. There's all different kinds of filter keywords you can use. Once again, if you find yourself doing things besides just basic ad hoc querying, ask yourself if this is really business logic that should go somewhere else. But if you're just trying to affect the display of data that you get back, then this could be a way to do it. If you're interested in looking at what else you can do with OData filtering and the web API, where you want to go is odata.org. This is a vendor-neutral site, and it lists the OData protocol and the different things that you can do with it. Okay, I want to take a look at how these OData filters actually work in our URLs. I've pulled our URLs up in Firefox, and the reason why I've done that is because when you use Internet Explorer, it is going to get JSON back from the controllers, which is actually exactly what we'd expect. But in order to see how these filters really work, I wanted to use Firefox because you'll notice that it's formatting our data as XML. And so when we use the filters in the URL, you'll be able to see the changes in data right away, as opposed to us downloading a JSON response and opening it up in Notepad or something like that. So that's why your browser is a little bit different, so we can actually see these changes as they're portrayed in XML. So the first one I want to talk about is the actual word filter. You'll notice my URL up here, API, books, so we're getting all the data back on all the books. Filter is going to allow us to specify a criteria to trim these down. So what I'm going to do is I'm going to make a query string, and the keyword here is filter equals, and for this particular one, I'm just going to say ends with title wand. So when I send that filter in the URL, it just gives me back the one where the title ends with wand. So this is a pretty common way to do things like trim down to certain IDs, or filter out the prices that are less than $15 or whatever it is you want to do. Now, I do want to reiterate at this point that this is just finding what ends with the word wand, so it might just be a simple search. But a lot of these filters, you really want to take a moment and think about whether or not these filters are actually business logic. And what you want to do is just decide, are you just controlling what you want to see on the screen, or is your filter actually representing some query that's meaningful to the business? So if I'm doing, say, a reporting application, then I might not want all my filters to be based in the URL because those reports actually are based on business logic that I want to capture in the code. But, if I'm just trying to get rid of some stuff on my screen and maybe just look at people with a certain last name or people from a certain state or something like that, it's just a purely visual consideration, filter is a great and easy way to do that, and I'm not getting all that data back that I don't need. The next one I want to look at is order by. So first I'm going to go back to our default URL. I'm getting back all the books, and then I just need to pick something to sort by. You can see these are out of order if we're looking at author or alphabetical titles or the price or anything like that. So once again, I'm going to come up here to my query string, and I'm going to do $, order by equals, and now I pick which field I want to order by or which property I want to sort these by. So I'm going to pick price, and so by default it's going to sort these guys by price in ascending order. Okay? And we can use any field we want to and it will resort them. If I go back to, say, author, okay, now these are in a different order based on the author's alphabetization. So order by, very nice for sorting columns. It's something we do in web applications a lot. You click on the column header and you sort a grid. This can be a great, easy way to do that without having to bury your logic for this all the way down in your business layers. So the next one I want to talk about is paging. And remember, this one's going to be a little bit more complex because we actually need to use 2 keywords to do this. And also, you'll notice I don't have a ton of data here, so if we make a page with 10, that's not really going to show you all that much. So our pages are going to be really, really short. So you might think about this almost like we're going to build an application where maybe we're looking at these books like a Rolodex or a card catalog or something like that. So the first thing I want to show you is the query string where we use top. I'm going to set top equal to 1. It will give me the first result. Now, while we're in the neighborhood, I do want to point out that we can combine these filters. So I could do something like order by equals price and top equals 1. And now I've got a different record up because the sort order is different, and then it gave me the top 1. So you can combine these filters with an ampersand just like any other query string data. I'm going to go back to top. Okay, no sorting, no filtering, no nothing. This is just book ID 1 is the first one we get. Okay, now let's say I've got some paging involved. I only want to show one book at a time. So, if you use your imagination, in a client-side web app, I might have arrows that page forward and backward. So when you click the arrow to go forward, I still want to return just one record, so top isn't going to change. However, I do want to incorporate the fact that I now want to skip over the first record. So I have skip equals 1 and top equals 1, and now I'm looking at ID 2. Next page, I want to skip the first 2. Right? So I'm incrementing this in terms of my page size. And once again, I just have 3 books, so the page size is pretty small. But if my page size were 10, then these increments would look different. Obviously, I'd skip the first 10 records, and then the next page would be the first 20 records, and so on and so on. So when you're generating these hyperlinks in your application, or however you're wanting to use these, just make sure you're doing the math correctly here, that you're skipping the records that you need to in order to get the exact set that you want. And this is great functionality to use client-side because at this point it is virtually a purely client-side consideration, and it has the benefit of only getting this data. It's not getting all the data from the database and then filtering out the ones we want. It's actually only returning the data that we want. So this can be a great way to accomplish some common filtering tasks on the client side.